And we're going to go on and get started with this here. Now, we're not going to do everything in the note sheet because looking back at it, there's some of the stuff that's over and beyond, and we're just going to move past some of it. But the first thing we're going to look at is absolute value equation, solving an absolute value equation. The first main step in solving an absolute value equation is to get the absolute values by themselves. We need to get the absolute value by itself, and then we can solve from there. So whenever we see this one here, 2 times the absolute value of 3 minus 2t is equal to 6, we need to get that by itself. And the only thing that we have to do for this one here is to divide both sides by 2. Because if we divide both sides by 2, we have the absolute value of 3 minus 2t is equal to 3. And that's our first main step, is to get those absolute value bars, the absolute value, whatever's inside of it, by itself first. Now, once we get it here, the absolute value is always going to have to equal a positive number. Once we get everything away from it, we've moved all the addition, subtraction over, multiplication, division, we've gotten it by itself. And if this equaled a negative number, so if this had equaled negative 3 instead of 3, it's no solution, we're done. Because the absolute value, the number that comes out of the absolute value, is always positive. It's always positive. Now, what's inside the absolute value can be positive or negative, because the absolute value of 3 is still 3. The absolute value of negative 3 is positive 3. So once we get it here, really, 3 minus 2t can equal 3. But 3 minus 2t could also equal negative 3. Because the absolute value of 3 minus 2t is 3, but what's inside it could be 3 or negative 3. We have one of these two cases. So we now just have to solve from here. So the first thing we can do is subtract 3 from both sides, telling us that negative 2t is 0. Then we divide both sides by negative 2, telling us that t is equal to 0. And that is one of our solutions. Now we're going to do the exact same thing on the other one. We're going to minus 3 from both sides. And when we minus 3 from both sides, we get that negative 2t is equal to negative 6. And then again, we can divide both sides by negative 2, telling us t is equal to 3. And that's it. Both of these are the solution. If one of the numbers seems very off, it doesn't seem like it's the right answer, all we've got to do is go back to the starting problem and plug it in and check it. So we could say 2 times 3 minus 2 times 0, absolute value is equal to 6. Well, 2 times 0 is 0, so we just have the absolute value of 3. Absolute value of 3 is 3, and 2 times 3 is 6. 0 works. Okay. We can do the exact same thing, but this time we can plug in our other answer of 3. 2 times 3 is 6. 3 minus 6 is negative 3. Absolute value of negative 3 is 3, and 2 times 3 is 6. So both of these solutions work. And that's really the main thing with these here. With any of these absolute values that we're dealing with, we're getting the absolute value by itself. And if the absolute value is equal to a positive number, we split it into our two cases and go from there. One where the other side's positive, one where the other side's negative, and solve. Any questions on this here? Probably been a while since y'all done absolute value equations, but they're not that bad. Now let's look at the other one. Again, whenever we solve these absolute values, we need the absolute value by itself first. That's the first thing we need. So we can minus 8 from both sides, which will tell us that the absolute value of 7w minus 3 is equal to -6. Well, as we just said, the absolute value of a number is always positive. Yes? So, is there any way the absolute value of 7w minus 3 will ever be -6? No, this is not true. This is no solution. We're done. It will not work. And we could go through, you can go through and solve it all the way down, but when you plug those values of w back in, they won't work. They won't give us a true solution. Questions on this here? I'm going to come back to these later if we do have time to hit them. We'll cover them. They're not that bad. We're not covering them in here. Mainly for time constraints. And that's even if you were taking this at NEO. It's a lot of stuff to cover, and yes, not a lot of time. Now, solving a radical equation. We've done these before. And we've done them in Algebra 2 more in depth than what we're going to do in here. Whenever we solve these here, we want to isolate the radical. Get it by itself, just like what we did with absolute values. We want to get it by itself. If an equation has more than one, choose one to isolate, or as I say, even them out. Even them out. If we have 2, I want 1 on either side. If I have 3, I want 2 and 1 or 1 and 2. I'm going to split it up. If we have 4, I want 2 and 2. We want to try to even them out as best we can. Now, even at college algebra, most of what you'll do is 2. You really will not see 3. Because once we get higher than that, it just gets harder and harder to work, and it gets really tedious. Once we do that, raise each side of the equation to a power equal to the index of the radical. If we have square roots, we're going to put both sides to the second power. If we have cubed roots, we're putting both sides to the third power, and so on, so that the radical will cancel. Solve the resulting equation. If the radical still has if the equation still has a radical, repeat steps 1 and 2. We just go back through the process again. And then check the potential solution in the original equation to write the solution set. What we're really checking for is extraneous solutions, values that we do get from solving that don't work in the original problem. Most extraneous solutions, they will occur if the variable is outside the radical. Is outside the radical. We have a variable inside and outside the radical. Most likely that's when an extraneous solution is going to occur. That's when they're most likely going to come up. So we'll look at this first one here. Square root of x plus 10 minus 4 is equal to x. And again, our first main step is to get the radical by itself. We want to get it by itself first. So the first thing we can do here is add 4 to both sides. If we add 4 to both sides, we get the square root of x plus 10 is equal to x plus 4. Is the radical by itself? Yeah, it's by itself. So what we can do is put both sides to the index of the radical, which is 2. Since it's a square root, we're going to square it. Because the square root and square over here will cancel, leaving us with x plus 10 is equal to on the other side, we have x plus 4 squared, which is really saying that we have x plus 4 times x plus 4. We can't just square the x in 4 and get the correct statement. Multiply through x times x is going to give us x squared. X times 4 is going to be plus 4x. 4 times x is plus 4x. And lastly, 4 times 4 is plus 16. Now we can combine like terms. 4x plus 4x is 8x. Now at this point here, we can move everything to the same side, because whenever we have a quadratic, we are going to need this equal to 0. So what we end up with is that 0 is equal to x squared plus 7x plus 6. Questions on this so far? Now at this point here, we could graph it. We could use the quadratic formula. We can use completing the square. We can use any of these methods. For this one here, we'll go on and graph it, because I think we've seen most of the others. We haven't touched graphing too much. We did it in Algebra 2 for quadratics and higher degree polynomial functions. And y'all do all have the 84s, because I gave them to you. So all we got to do is hit y equals, and we can type the function in. So we have x squared plus 6x plus 7, no, other way around. 7x plus 6. And we can hit graph. And what we're looking for is the x values that make y equal 0, or here are the y values that make x equal 0, vice versa. We're really looking for where it crosses the x-axis. What values of x will make the value of y be 0? And we see it does cross in two places. Second table. Well, one of them is at -6. The other is at -1. So what that tells us is that the value of x that will make this equal 0 is when x is equal to 6, -6, and when x is equal to -1. -6 and -1 are our two solutions. Now our original equation was the square root of x plus 10 minus 4 is equal to x, yes? We need to plug these back in to make sure that they both work. So we can do -6 first. Square root of -6 plus 10 minus 4 is equal to -6. We could put these in parentheses if we need, especially if they're being squared, have something being multiplied by them, just to make sure the negatives are taken care of properly. Now here we have -6 plus 10 is 4. Well, the square root of 4 is 2. 2 minus 4 is -2. And -2 does not equal -6. So -6 does not work. Questions on this here? And really, we could have typed the whole left side into the calculator. We can done square root parentheses -6 close parentheses plus 10. Move outside this radical, -4, enter, and see what it gave us. And it told us it was -2. That's not the same as -6. We're done with that one. All right. Now we can do the same thing with -1. So we can say the square root of -1 plus 10 minus 4 is equal to -1. So I can plug in the calculator. Second square root of -1 plus 10 minus 4 is -1. So we know this entire side is -1. The other side is -1. That works. So the only solution for this here is -1. The other one is an extraneous solution. It's a solution we get from solving that does not work in the original problem. Questions on this here? We good with this here? Would we like to see another example of one of these? Or do we feel comfortable with this? Feel pretty comfortable with these? Awesome. We're not going to encounter ones like this here. Now, I do want to look at this one here so we've seen it and know how this works. So we have 2 times x plus 1 to the 2/3 is equal to 8. Whenever we have a set of parentheses, and the variable is only contained in the parentheses, we don't have 8w on the, or 8x on the other side, there's no variables outside of it, get those parentheses by themselves. Get that by itself. Because we can divide both sides by 2. Which will tell us that x plus 1 is equal to, x plus 1 to the 2/3 is equal to 4. Now, this here, I feel like y'all could get to this here. This here is not too bad. But from here, it's a little tricky knowing what to do, especially with the 2/3. Well, as a side note, if we said x squared, how would we reduce it? Well, we would take the square root, yes? Well, the square root is really just the same as saying I'm multiplying this or applying the 1/2 power to it. Because 2 times 1/2 is 1, yes? When we square root, or square root, we're canceling that power out. So what we can do here is we're going to apply a power to both sides. But we won't apply the 2/3. We're going to apply the 3/2. Because powers of powers multiply. Powers of powers multiply. And this is a very interesting method that we can use, and it's even more interesting that it actually does work. Because if we multiply these together, powers of powers multiply, the numerators would multiply with the numerators. So 2 times 3 is 6. Denominators with denominators. 3 times 2 is 6. Well, what is 6 over 6? 1. So this here really just reduced to 1, which in essence leaves us with x plus 1. Now over here we have 4 to the 3/2. 4 to the 3 over 2 is 8. Now, there are some issues with powers, because if we take the square root, especially fractional powers, if we take the square root of both sides, we have to add the plus or minus. Because the positive negative case, depending on what it is. Now, there's an easy way to check and see. So if we said -4 to the 3/2, domain error. Doesn't work. So 8 to the 2/3 is 4. -8 to the 2/3 is still 4. What I'm doing is looking back at the original power, 2/3. The numerator and denominator have a certain expectation to them, and it's going back to this here. The nth root of a to the x is the same as the a to the x over n. A to the x over n. N tells us what root we're taking. X tells us the power applied to it. So really what this is saying here, x to the plus 1 to the 2/3, well, the 3 on bottom tells us we're taking the cubed root of x plus 1 squared. Cubed root of x plus 1 squared. So when I apply the 3/2 power, we're cubing it to get rid of the radical and then taking the square root of it to get rid of the power of 2, which means we have the plus or minus case. So whenever we apply this to both sides, if the denominator is 2, we're going to have to add the plus or minus. If the denominator is 3 or an odd number, we don't have to. Even we apply it, odd we don't. So it's telling us x plus 1 is equal to plus or minus 8, which really means we have 2 equations. And we can solve from here. So the first one we can, minus 1 from both sides, telling us x is equal to 7. We can do it for the other one. We can minus 1 from both sides, telling us x is equal to negative 9. And we have these two answers here. Two. Yeah. 2/3 is equal to 8. And again, we can check the numbers to make sure that they work. So we can say 2 to the 7 plus 1 to the 2/3 is equal to 8. And we have 2 to the negative 9, or 2 times negative 9 plus 1 to the 2/3 is equal to 8. In the calculator, we can say 2 parentheses 7 plus 1 to the 2/3. And we get a value of 8. So that tells us that here 8 is equal to 8, so it works. We can do the other one. 2 parentheses negative 9 plus 1 to the 2/3 is still 8. So here 8 is equal to 8. So both of these here are our solutions. Does this make sense? So for this one here, again, to solve it, we want to get that set of parentheses by itself. So these here are going to cancel, telling us that x minus 4 is equal to, x minus 4 to the 3/4 is equal to 27. And again, to simplify this here, we're going to put both sides to the 4/3. Now, is the denominator for this one here odd or even? Odd. It's an odd number, which means, for one, this here, our 27, is not going to need the plus or minus. Because we can plug it into the calculator, say 27 to the 4/3, which tells us that it is 81. So it simplifies to 81. And that's what we get. Now, if we went the other way back, saying 81 to the 3/4, we'll still get 27. If we do it with negative 81, kind of saying our plus or minus to the 3/4 domain error, it doesn't work. It only goes one direction for these here. Because if we're going backwards, kind of going back from here to here with the positive negative case, it doesn't work. So saying that this here, that the x minus 4 is negative 81 inside what we get, doesn't work for this problem. Does that make sense? Can we see the difference between those two? Because here we're taking the 4th root. We're taking the 4th root of a number. That has to be positive. We cannot take the even root of a negative number. In the previous one, we weren't taking an even root, we were taking an odd root, 3. We can take the odd root of a negative number. We can't take the odd root of an even number. So here, this just has to be 81. And over here, these will simplify, leaving us with x minus 4. We can add 4 to both sides, telling us that x is equal to 85. And that's the answer. Questions on this here? So for this here, 54, not 8. We can graph it. But in order to graph it, we need this equal to 0. So we move everything to the same side. And what we can do is we can graph it. Doing this, we're trying to find out what value of x will make this equal 0. The function doesn't show up. Because here it's only going from negative 10 to 10. Now, we can look for 0. And we'd have to find left bound, right bound. We can go second graph. And we can try to look here going down. Now, since we're subtracting 54, there's a good chance that it's going to be pretty far down there. And there it is, 85. Now, we could have done this with our 0, so I could calculate 0. Left bound just means that we want to point to the left of where it crosses. And I'm going to keep hitting the right arrow, so we got a number. And we're looking for where it crosses the x-axis. So right now the y value is negative, yes? So I'm going to keep going until it hits a positive number. It doesn't matter what it is, but it just has to be a positive value. Yep, nope, I think I got off the line. Yep. Yeah. Yes. Yeah. We'd have to have a sign change. So that one's a little challenging to do it that way, but it is possible to do that. Does that make sense? So we can graph them to see where they cross the x-axis. Questions on this here? Okay. This one here is going to apply one of the most useful things that you can have in solving. Now, this seems like it's something that's going to be crazy to try to solve. And this thing is actually factorable. Now, the way we do this and solve this is something called U substitution. U substitution. For those that had me in algebra or in trig last semester, we've used this. And what U substitution does is we take U and set it equal to a certain value or a certain expression. Here, we're going to use U as 2x squared minus 3. 2x squared minus 3. So for us, anywhere 2x minus 3 shows up in the equation, we're now going to replace it with U. So here, 2x minus 3 squared, this is now U squared. Plus 36 times, well, the 2x minus 3 is now U plus 35 is equal to 0. So we've taken it from something that looks very not pretty to something that actually looks nice, or at least nicer. Now we can factor this here. Since the 35 is positive, the signs are the same and they match the sign of the middle term, which would be plus and plus. Our factors of U squared are U and U. Now there's a lot of factors at 35. but the ones we're going to want are 1 and 35. Questions on this here? Now we have two things multiplied together to equal 0, so one of them must be 0. So either u plus 1 is 35, or u plus 1 is 0, or u plus 35 is 0. And if we solve these here, we get u as -1. And over here, we get u is equal to -35. Questions on these so far? Okay, you come down here. Down here. Now, u is just been a replacement. It's been what we substituted it in for. Because what is u? 2x squared minus 3, yes? Once we get it solved for u, we replace that back in. So really what we're saying is that 2x squared minus 3 is -1, and 2x squared minus 3 is -35. We use the u till we get it solved, and then replace it back in. Now we just have to solve these here. So for this one here, we would add 3 to both sides, telling us that 2x squared is equal to 2. Divide both sides by 2, telling us x squared is equal to 1. And last but not least, square root both sides, telling us x is equal to plus or minus 1. And if we did this in the calculator, we graphed it, we would get positive to -1. Even if we plugged it in as the original equation, it would give us positive -1 on the graph. Let's look at the other one. So here we would add 3 to both sides, telling us that 2x squared is equal to -32. Then we would divide by 2, telling us x squared is equal to -16. Square root both sides. X is equal to plus or minus, because the square root of 16 is 4, but since it has a negative inside that radical, it comes out as I. Plus or minus 4i will not show up on the graph, because when we graph a polynomial function or a higher degree polynomial function, we always graph it in the real plane. So negative or positive 4i does not show up on the main graph. Questions on this here? U substitution is very useful, especially if you go on and take calculus or anything higher, because it takes a lot of functions that we normally wouldn't be able to see or would be difficult to handle factoring and solving, and makes them a lot easier to factor and solve. And see how they factor and solve. Questions on this here? If we have time to come back to this one, we will. I want to look at this one here, because this one here is still U substitution. We can still solve this by U substitution. However, first thing we're going to have to do is get everything on the same side of the equal sign. So we can minus 3w to the 1/3. We can also minus 20. And if we minus both of these here, we get 2w to the 2/3 minus 3w to the 1/3 minus 20 is equal to 0. Now the big question is, what will we set u equal to? Now for most of these here, especially for quadratics, they're kind of nice. because the middle term is what we'll be using. So our middle term in this case is what? So we wouldn't look at the 3, mainly the variable w to the 1/3, yes? So if I said u equal to w to the 1/3, for the middle, it's not that bad. It'd be minus 3u minus 20 equals 0, yes? Now w to the 2/3. W to the 2/3 is the same as what? W to the 1/3 squared, yes? So really this is 2u squared. And I mean, it works like this for pretty much most of the time. If we set, say, w was 1/2, what would happen if we square it? We would just get w, yes? Which would look a little funnier if it was that way, because then it'd be w plus w to the 1/2 plus, or we can say 2, plus 1. Because then we can use u as 1/2, and we still get u squared plus 2u plus 1. Sometimes it works a little funny. But we can still use that middle term here as a way to find out what u is. Because whatever that value is, if we square it, we should get the variable for the first one. W to the 1/3 squared is w to the 2/3. U to the 1/2 squared is u to the first. Now this here is a little bit easier to work because we can factor it. Since the 20 is negative, our signs are opposite. The only factors of u that we have are u and u. Now the factors of 2 are 2 and 1. And our factors of 20 are 1 and 20, 2 and 10, 4 and 5. Now out of all these here, 2 and 10, I'm going to just take off the list. Because no matter how I put 2 and 10, if I put the 2 with the 2, we have a greatest common factor of 2. If I put the 10 with the 2, we still have a greatest common factor of 2. And if I look back at this one before it, 2u, 3u, 20, there is no greatest common factor. So 2 and 10, we can take it off the list to begin with. 1 and 20 is probably going to be too big. So we're looking at 4 and 5. So 5 and 4. Let's see, I'll make sure I'm not missing any. And see what we get here. Because 2 times negative 4 is going to be negative 8 u. 5 times u is plus 5u, and this is equal to negative 3u. Actually worked out. I was afraid it wasn't. So we get this here. So it's telling us that 2u plus 5 is 0, and u minus 4 is 0. And we just have to solve from here. Minus 5 from both sides. Tells us that 2u is equal to negative 5. Divide by 2. Tells us u is equal to negative 5/2. We can do a similar thing with the other side. We can add 4. Tells us u is equal to 4. Now, what did we say u was? U was W2, the 1/3, yes? So at this point, we've got to plug it back in. So here, I'm just purple. Actually, no. Let's go with bright green. W to the 1/3 is equal to negative 5/2. And here, W to the 1/3 is equal to 4. So the last thing we need to do to get rid of those exponents is to put both sides to a power that will cancel that exponent out. Since 1/3, really, we're flipping it like we did earlier. So the flip of 1/3 is 3, because 1/3 times 3 is 1, telling us W is equal to, calculator, -5, oh, okay, clear. -5 over 3, no, it was 2. 2, we have to the third, yep, is -125 over 8. And that's one of our solutions. We can do the same thing here, put both sides to the third power, telling us W is 64. Now here we don't have two cases, because with cubes, it works out to be a number. Because if a negative number is cubed, it still stays negative. If a positive number is cubed, it stays positive. And that's it. Does this problem now look way easier than it did when we looked at it 2 seconds ago? That's what the amazing part of U substitution is it takes something that looks like it's going to be incredibly difficult to solve, turns it into something we can solve, and then we put it back in to actually solve it from there. Questions on this here? Is there one of these that we want to see worked? Another one that we've done so far? Or do we feel pretty comfortable with them right now? Yes. There is one other one that, since we do have time, I do want to look at. This here, there are going to be problems, literal equation problems, like this here. And it's going to say something like, solve for R. And all that means is get R by itself. We want to rewrite it so R equals everything else. Now, if we look at this here, R is in the denominator, yes? So we need to get rid of the fractions. And the only way to do that is to multiply everything by the denominators. So here, P and P will cancel, telling us that we have 7R. Here, R and R will cancel, telling us that we have plus 9P is equal to SPR. We're comfortable with that step, yes? Now, most of these here, when we solve for stuff like this, what we're doing, one, is to get rid of the fractions. Two, get everything that has R, whatever we're wanting to get by itself, on the same side. So what we'll do is subtract 7R from both sides. These here will cancel. And it'll tell us that 9P is equal to SPR minus 7R. This seems really weird if you don't know what's coming. Because it's like, why do we do this? Why are we setting this up? And the reason we're doing this is because if we look at the right-hand side now, is there a greatest common factor between those two terms? Yes, they both have R in common, yes? So what I can do is I can factor it out, which will leave us with SP minus 7, yes? Well, we've gone from one equation with only one R in a denominator to a single equation where we had R in two places. Now we're back to R in one, yes? Well, if I divide this here by SP minus 7, what's going to happen? These two are going to cancel out, yes? Over here, we're going to have SP minus 7, which is really telling us that R is equal to 9P over SP minus 7, and that's it. So especially with stuff like this here, get rid of the fractions first. Try to get whatever variable you're solving for by its all on one side, factor it out, then divide, and that's it. Okay? If you do have questions about stuff like this or on 1/6, please ask. I will respond pretty quickly. I've normally been writing on the picture, especially send me a screenshot so I can see it. and work from there because they do change. If y'all have noticed that, you've opened an assignment, reopened it, some of the problems flip around. So do send a screenshot. I will respond back pretty quickly on that there. We will cover 1.7 next week. Your test over chapter 1 is next week.